Hello everybody, welcome to Science Today TV YouTube channel. Today we want to talk about the latest update on ozone hole that is slightly getting smaller. The NOAA ozone sonde, an instrument used to help scientists monitor the Antarctic ozone hole, ascends over the South Pole in the time-lapse photo taken 21st of October 2020. The hole in the ozone layer, the portion of the stratosphere that protects our planet from the sun's ultraviolet rays, is continuing to decrease. The whole of Antarctic had an average area of 8.91 million square miles. It defines 23.2 million square kilometers. That measurement is slightly smaller than the extent of 8.99 million square miles or 23.3 million square kilometers reached last year, and well below the average seen in 2006 when the hole size peaked. Over time, steady progress is being made and the hole is getting smaller, said Paul Newman, chief scientist for Earth Sciences at NASA's Goddard Space Flight Center. We see some wearing as weather changes and other factors make the numbers wiggle slightly from day to day and week to week, but overall, we see it decreasing through the last 2 decades. Eliminating ozone-depleting substances through the Montreal Protocol is shrinking the hole. The ozone hole happens when the protective ozone layer in the stratosphere above the South Pole begins to thin every September. Chlorine and bromine, drift from human-produced compounds, are released from reactions on high-altitude polar clouds. The chemical reactions then begin to deplete the ozone layer as the sun rises at the end of the winter in the southern hemisphere, with the strongest depletion occurring above Antarctica. Different methods of measurement. NOAA and NASA researchers detect and measure the growth and breakup of the ozone hole with satellite instruments abroad. Ozone MPP and NOAA 20 satellites. This year, satellite observations determined the ozone hole area reached a single-day maximum of 10.2 million square miles or 26.4 million square kilometers on October 5, but is now shrinking. NOAA scientists at the South Pole Station also record the ozone layer's thickness by releasing weather balloons carrying ozone measuring instruments called ozone sondes that measure the varying ozone contractions measured in Dobson units as the balloon rises into the stratosphere. The lowest column amount detected by ozone sondes at the South Pole this year was 101 Dobson units on October 3. According to Brian Johnson from NOAA's Global Monitoring Laboratory. This is very similar to last year's measurements. At altitudes between 8 and 13 miles above Earth's surface, the ozone was almost completely depleted during the ozone hole's maximum. The ozone layer provides powerful protection against the sun's ultraviolet rays, but is startlingly thin relative to the Earth's crust and ocean, or even its total overhead atmosphere. In many places, the global average is about 300 Dobson units, which if brought down to sea level pressure is about as thick as 2 stacked pennies. Over Antarctica, the depleted ozone layer is roughly equivalent to the thickness of a dime. Factors affecting this year's ozone hole. Measurements made via satellite and ozone zones show that the Antarctic ozone hole has been smaller in recent years than it was in late 1990s and early 2000s. This is due to the Montreal Protocol, a treaty adopted 35 years ago to ban the release of harmful ozone-depleting chemicals called chlorofluorocarbons or CFCs. It remains the only international treaty ratified by every country on Earth. Amendments have helped it evolve over time to meet new scientific, technical, and economic developments and challenges. Scientists were also concerned about potential stratospheric impacts of Hunga Tonga Hunga Hapai volcano eruption on 15th of January 2022. But so far, no direct impacts on the ozone layer have been noted in the data.